आज का हमारा टॉपिक है इलास्टिक डिफॉर्मेशन. टू अंडरस्टैंड द डिफॉर्मेशन फर्स्ट, elastic deformation, first we understand what is deformation. So when I say deformation, deformation is change in shape. Is change in shape. So when you apply the force on an object and this object changes the shape, so this is called deformation. Now, sometimes some object has the tendency that when you apply the force, they change the shape, and after the removal of the force, they return back to the same shape. If this happens, this type of deformation is called elastic deformation. So when I say what is elastic deformation, elastic deformation when an object regain its original shape after removal of force so this type of deformation is called elastic deformation. Okay, so if an object returns back to the same shape when you remove the force, this type of deformation is called elastic deformation, and such an object is called elastic object. For example, we have rubber band, we have a spring. They are all elastic object because you apply the force, they stretch. When you remove the force, they return back to the same position. If I explain this all the things with the help of a spring, just have a look here. I'm hanging a spring there. This is a spring. Let's suppose its initial length is from here to here is L naught. Now I applied some force let's say that I have hung some weight with this spring. So I hung a weight onto this one. Say the weight is W. And after hanging the weight, the new length of the spring is from here to here. Let me call it L. And the change in length from this position to this position, let me call it X. So by the diagram only we can understand this change in length X is equal to L minus L naught. So this change in length is called extension. Now what is extension? Extension is the change in length when force is applied on an elastic object. So in this case, x is the extension or change in length. So extension can be found by original length um, and extended length subtraction. So L2 is the extended length, L is the original length. You subtract both of the two and you will get the extension. Now there is a law associated with this. We call it Hooke's law. Hooke's law actually gives you the relation between force and extension or load and extension. The statement of the Hooke's law says that within the limit of proportionality, extension is directly proportional to the applied force. This applied force actually also refers to load. So you can replace the applied force by the word load as well. In this case, this weight is load. So when I write it mathematically, extension, x is the extension, is directly proportional to the applied force F. After introducing the constant, the relation will be F is equal to Kx. What is K? K is a constant. K is a constant number and its value depends on type of the spring. For example, if a spring is hard to stretch, so the value of K will be greater for that spring, or vice versa. A soft spring have less value of K. So K is also referred to the spring constant. A spring constant. So if I make the subject K, K is equal to F over X. So according to this formula, I can define K that what is K? It is force per unit extension. So force per unit extension, or if you are taking all the standard units, so K will be equal to Newton per meter, its unit. Or if you are taking in centimeter, you can say Newton per centimeter, and so on. Now we all know that if two quantities are directly proportional, what type of graph they are having? They will have a graph which is straight line, passes through origin. So let me draw the graph. If I take extension on y-axis and force on y-axis, so the graph will be a straight line, passes through origin. So this graph representing the graph of a material that strictly follows the Hooke's law. It has a straight line that passes through the origin. As we have discussed that when the two quantities are directly proportional to each other, the graph will be a straight line that passes through the origin. Look at another graph. Okay, force on x-axis, extension on y-axis, and we have a straight line. But after some time, this straight line start bending, like here. So this is the point where the line start bending. This point is called limit of proportionality. Why limit of proportionality? Because that is the maximum point or maximum force until that extension and load are directly proportional. And that is exactly Hooke's law. Hooke's law said that extension is directly proportional to the applied force. So beyond that point, extension is no more directly proportional to the applied force. So that is the last point till the extension and force are proportional. So this is why this point is called limit of proportionality. We can define limit of proportionality as it is the point till that extension is directly proportional to the applied force. And till that their graph will be a straight line. So what is limit of proportionality? It is the point till that extension and load are directly proportional, or if you are seeing a graph, it is the point on the graph till that force and extension has a straight line. So this question frequently come in the examination, that mark the point that has limit of proportionality. What you're supposed to do, you just need to put a scale with the line, and until that the line is straight line, the graph is within the limit of proportionality. Beyond this point, the graph has crosses the limit of proportionality. Now one more point you have to remember, that whenever the limit of proportionality exceeded, in most of the cases the extension will be more than the usual. So that is why graph bends towards the extension. Like in this case, you can see the graph is bending towards the extension. Extension is on y-axis. So after the limit of proportionality, graph is bending towards the y-axis or towards the extension. Remember, whenever the limit of proportionality exceeds, the graph will bend towards the extension graph. Whenever if the extension is on y-axis, it will bend towards the y-axis, or if extension is on x-axis, it will bend towards the x-axis. Except few cases, a very few cases are there where the case is different, but in most of the cases, after the limit of proportionality, the graph will bend towards the extension. Like, let me discuss one more example. Like if the situation is this one, I plot the graph this way. Extension, if I keep the extension on x-axis and force on y-axis, the graph will be a straight line. And how long it will be a straight line? As soon as the limit of proportionality exceeds. Now in this case, extension is towards the x-axis. So in this case, the bending of the graph will be towards the x-axis. So this will be the limit of proportionality. Now, how can we draw the graph of load and extension in an experiment? So when we perform this experiment on a lab, so here we are going to do the experiment. To verify the relation between force and extension, the first thing what we have to have a stand. So let me have the stand. This is a stand, and along with the stand, I'm going to take a meter rule, This is a meter rule. Here is a pin. And a spring. The spring with attached with a pointer. Here's the pointer. And along with the pointer, we have a hanger. This hanger can have some weight. So these are basically weight or load. This is a spring. This is ruler. This is stand. Now how to perform the experiment? Here we are going to draw a observation column. Observation number. Initial reading, say L0. This is in centimeter. Then after the loads are applied, final reading L. This is also in centimeter. When you subtract the two readings, you will get the extension, X in centimeter. And how can you get the X? As we have discussed earlier, L minus L0. You got the extension. Then how much load you are applied. Let me call load as F. This can be in gram. Mostly in the lab it is in gram. Okay, so the observation number 1. Let's suppose, it is just supposition. Let's suppose the initial reading when there is no load, when there is no load is 0, say like 5 centimeter. Okay, and after you put, you haven't put anything load there. So final reading also 5, so extension will be 0, load is also 0. Now you applied a load. Let's suppose you put the load of 20 grams, sorry. So now the new reading is just suppose 7 centimeter. This will remain same because it is initial reading. It won't be changed. Okay. So 7 minus 5 is 2. Then let's suppose you applied more reading, more load. Say now the total load is 40 because you put 20 more. So new length will be 9, extension will be 4. Applied more, 20 plus, so it will be now 60. The new reading is 11, and 11 minus 5 is 6, and so on. What you have to do, you just keep adding the load and note down the new pointer reading, and from each pointer reading you have to subtract the initial reading L0, the reading without load, initial reading. So you will keep getting the extension. So now you have the values of, here it is, extension and load. Take the 4, 5 readings, and then taking the load on x-axis and extension on y-axis, you can plot the graph. Now one more thing, we have earlier discussed that how you find that whether the limit has exceeded or not, because after the limit has exceeded, the graph will no more a straight line, it will start bending. Now in case if you have given the data, how you find whether from the data whether the limit has exceeds or not? It's a quite simple thing. For example, I am going to put some values, load and extension. Now look at this. Let's suppose the load is 20 Newton, extension is 2 centimeter, then 40, extension is 4, then 60, extension is 6, 80, extension is 8, 100 extension is 10, and 120 extension is 13. So what you have noticed, at each position the change in extension is same, 2 centimeter, 2 centimeter, 2 centimeter, but here it is 3 centimeter. So it means that limit has exceeded between 100 gram to 120 grams, somewhere limit has exceed. So if you have given the data, how you will find whether the extension is cross exceed or not? That the extension will be different. Before the limit has exceed, extension will be the same, but after the limit exceed, extension will be more than the usual. So this is how you can find out. Remember, the two graph, look carefully. This is extension and load graph, or force, whatever you say. This is length and load graph. When you draw the graph, within the limit of proportionality, extension load graph will be a straight line that passes through origin. But length and load graph may not be passes through origin. Why? Because when the load is 0, there must be some length of the pointer as well, because spring has its own length. So this length from here to here, this length, what do you call this length? It is known as unstretched length. Unstretched length is the length of the reading on the pointer when there is no load. So this graph clearly shows that extension is directly proportional to the load, because the graph straight line passes through origin, but length is not directly proportional to load. No, length is not directly proportional to load, because the length load graph is not passes through origin. So you have to keep this thing in your mind when you are solving the question. Okay, here we are ending the class. Before ending the class, let me review all the things what we have learned today. Okay, we have discussed the elastic deformation, and before that we discussed that deformation is the change in shape. And what is elastic deformation? It is the change in shape, and when an object regain its shape after the deformation, after removal of the force, this type of deformation is elastic deformation, and such an object who has elastic deformation is called elastic object, and this property known as elasticity. So extension may be found from this graph. Extension is equal to L minus L naught. L is the final length, L naught is the initial length of the spring. Hooke's law statement, you don't have to memorize Hooke's law, but you have to have a very good understanding. Within the limit of proportionality, extension is directly proportional to the applied force or load. So extension proportional to F, F is equal to Kx. K is known as a spring constant, and K is equal to F over X. So K can be defined as it is force per unit extension, or its unit will be Newton per meter, or if you are taking the length in centimeter, it will be Newton per centimeter. Extension and force graph will be a straight line passes through origin, because it follows these quantities are proportional to each other. And the point after that, the graph will no more a straight line. This point is known as limit of proportionality. What is limit of proportionality? The point, maximum point till that extension and load are proportional to each other, and the graph follows the Hooke law. Beyond this point, the line will not be a straight line. Remember that extension after the limit, the extension of the graph will be the bending of the graph towards the extension. On whether the axis extension is on x-axis or y-axis, graph will bend towards the extension. Then this experiment will help you to find the relation between force and extension. You have a steel stand with a spring, a ruler, and a hanger that has some loads. Keep on putting the load and find the pointer reading. And after each pointer reading, subtract the initial reading. This is initial reading. And you will get the extension and note down the force. Normally in lab, force is in gram, load in the gram. Okay, so then you can draw the force extension graph. And if you are given the data and you have to find whether the limit is exceed or not, just observe the data carefully. Between the 2 points where the extension is unusual, extension is no more the same. Between these points, it means between these 2 points, the graph has or the spring has exceeds the limit of proportionality. And the last thing, that extension and load are proportional, graph would be a straight line, but length and load may not be directly proportional, because at zero length there must be some length, and this length is called unstretched length. Okay, this is the last point. So see you in the next class.